So this is the hardware of the sunspot. We can see that there are different layers here. The the back end is the battery. It's 720 mAh for that. Yeah, you know that. And this layer is the processor board, the main board. That this one here. And this is the sensor board, contains many sensors and I/Os here, and the sunroof for the lead. Okay, here's this one. This picture is the processor board. So we can see here is the main processor that's 180 megahertz, and antenna here. This is the communication module and the RAM and the raw flash here, right here, and this is protocol connector to connect the sensor board, and this is the power switch and the USB interface to connect your PC with the spot. Here's the sensor board. That's here. As you can see, here are 8 3-color LEDs here, and the light sensor, this small one, and also the push buttons here, the accelerator chip, temperature sensor, and also some input and output pins. Time synchronization. Time synchronization is a very important issue that it will affect the security if the time difference is more than 3 minutes. So how to synchronize the time? Actually, the time synchronization was done by every time you connect the spot to the PC. Every time using the USB to connect them, they will automatically synchronize the time between the PC and the host. PC and the spot, sorry. So in the later section, I'll touch some specification of hardware and also some code. Here is the memory with 512 KB RAM. There is a garbage collector in the virtual machine. That's so you don't need to worry about the garbage about the memory, and it will automatically fit. And also 4 megabits of flash. The address start from here. You can see that it reserved about 256 kilobits for the squad virtual machine. Actually, it's just 80 kilobits right now, but it's reserved this space for future. And you have 2 application slots here for the squad virtual machine that you can run multiple applications concurrently. So you can deploy not only just one application, you can deploy multiple applications in this spot. It's different from the Titan OS. And you have 2 megabits of the flash to store your data into that. So access flash.
Before you go into this one, do you also talk still about the cool sunroof or tinted windows for the racing cars, where we have a sunroof? So last time you mentioned, I just wanted to, it has a sunroof, you probably all saw that, right? And the question is, I know for sports car it looks great, but the question is, the sensor is not obviously sports car, so why do we need sunroof? And would you mind quickly explaining that?
For the sunroof?
Yeah. Because I thought it's still hardware related, now we go to the software stuff.
Just a laser to protect the device, I think right now.
But didn't you also tell me that the light sensor?
Oh yeah, I'll touch it later.
Oh yeah, we will touch it later. That's what I was wondering.
So access to the flash, we have 2 methods, high level method and the low level. The high level method is RMS, we just touched that, right? and it's very simple. Actually, the same as the K2AP in the mobile phone. Just open the record set. This is the name of the record set, and this is the data you want to store, and add this record of this data to that, and returns a record ID of that, and then you can get the record according to the ID, and close this one, close the connection. And the low level access is it's a bit harder, but you can do more things. You can access any part of the flash, which indicates by the address, by the starting address and the end address of this. You can access any. So you can touch a little bit more things than the RMS, but it's not very safe. So I recommend that if you just want to record something, use RMS. And here's the radio part. The radio integrated with personal area network. It's ISM band and it's free. And right now, the ZigBee is not implemented yet, but you can build it by yourself. ZigBee is a kind of protocol that will be the standard of the wireless communication between the small devices. And here's the address of every spot. The first two parts is predefined, and the second two parts is located the address of every spot. You can see it's printed here. It's this address is given after the manufacture. So for the ports, we have around 256 ports we can use but many of them are reserved for system use. As we know, their ports are used to identify different applications in the sport, in the different applications in the network. Here, in the Java Squad virtual machine provides two types of protocols, socket protocols. One is the radio stream, and the other one is the radiogram. Radio stream is much similar to the TCP in the normal network application, and the radiogram looks like UDP. The radio stream is string-based and reliable. It needs acknowledgement every time that when you communicate with the response. And the response, it's a P2P like socket. And for the radiogram, it's datagram based, and it's not. There is no guarantee about the delivery or the ordering of every package. So the package will arrive may be different. So the radiogram also supports the broadcast, and it's a kind of client and server architecture. Here's the code of radio stream. As you can see, it's very easy. Just 14 lines of code you can communicate between two devices in embedded system. Here you can see open radio connection at this address, and data input stream, data output stream, and write the message you want to the stream and flash it, and get the response by just read something. And the final part, you just close the connection and the input output stream.
I'm gonna ask one question just for all of you. Why do we have to access here the MAC address directly? So why doesn't it look like an IP address?
Is this automated service?
Sorry?
I think it has especially for the internet or something like that.
But Okay, but that's true, yeah. I mean, so that's obviously true what you're saying. So then I revise my question: why don't we, for instance, reserve IPs for sensor modes?
Yes.
Yeah, no, that's true, but I mean, maybe we could have a simpler protocol to still use them as an identifier, but the problem would be, as you can probably guess, if this vision becomes true, we will have millions of devices. We would run out very quickly of the IP address, so that makes it, and I think also, at least the people who took Eggman Center Network class this semester will probably know, for, I know your mobile device is precious, but a sensor, we would usually say, isn't precious. It doesn't matter. You're interested in data, not an actual device anymore. Because usually you would assume you have thousands of devices deployed anywhere. Whether one of them would fail doesn't really matter. You're just interested in the data you're sensing. That's, for instance, why people don't bother with IP address and things like that. So there are a number of reasons. Just wanted to point out, I think, in case you think, oh, that's weird that we have to now suddenly use the address.
What ways of trying IP
Yeah, actually, to be honest, it would be possible. You did have enough address, and you could have a live-wire protocol. People were actually thinking about it. And if you look into, actually, I spoke to David Culler. He's from UC Berkeley, and he's one of the big people in that. And there are some fights going on. What would be actually best? Should we actually have IP6 and deploy all that? Should we have a different protocol? I mean, by fights, I mean, not, what I'm trying to say is, people are trying to say this would be a better idea, that would be a better idea. Nobody knows actually what's going to happen. Everybody agrees at the moment we are just into the data. It's not so important, but obviously it would make things much easier to access data when we would have something like IP6. But no one knows, is the honest answer.
Yeah, sensor network is kind of data-centric application that we don't actually concern about every individual device, but the whole application works. And here is the client side protocol. It's very similar to the previous radio stream one. Just change it to the radiogram connection and open this. The port is 100 and get an instance of the diagram. Just write the messages to the diagram and send the message, and also you can and later you can just receive any packet that received and print out this one. It's much similar to the application in the normal Java, right?
Shouldn't be the message, the received message shouldn't block the whole.
Yeah, it's blocked.
It's like socket, right?
Yeah, very much similar to it. So here is the server side. The main difference is here. We don't specify the IP address because the address because it's a server application. We just open the 100 port number to receive any packet from outside. I just refer that the radiogram support the broadcast. So the broadcast is it's not really reliable. In default, it transmits the packet by two hops. I mean, from the base station to one sunspot, one hop, and to another one, two hop. This one will automatically replay this packet to another. So if the message is duplicated, it will ignore the packet. How to achieve this? Just change the datagram connection to specify that it's a broadcast. And what kind of port number you want to use to broadcast the packet? Specify here, and here's a line of code that you can change the default host you want to use. Just set the max broadcast host to anyone you want. it's a kind of flat protocol. Okay, here we touch about the sensors. You can see that there are accelerometer, temperature sensor, light sensor, three color LEDs, and the switches, and the input and output, input output pins. And we'll just touch about first four even. Yeah, first five, right? First five. Here's the three-axis accelerometer. As we know, the Wii controller is also integrated with the accelerometer chip, and it's very funny. It's very interesting to play with the Wii. But actually, the SunSport has much more powerful than the Wii controller. See that the chip in the Wii controller just provide one mode of the sensor, and but in SunSport you can change from two 2G gravity force and also provide a larger range of the sensitivity. In the small range of sensitivity, you can get higher resolution of your movement. In this one, you get a larger range of sense, but a bit lower resolution. And also, the SunSport, the chip in the SunSport support the slim model to save energy in the SunSport. So in SunSport, it's a general purpose application, unlike the Wii remote controller. It's carefully tuned for the movement, determine the movement of your arm and hand. But you also can do all the things which we can do, but you need to write code by yourself. Yep. Oh. Family is great.
So I think we'll be good. So there will be some demos. I think